awesome folks. How's it going? Could y'all confirm if y'all can hear me and see me well? As y'all can tell, I'm not in my usual location of streaming. Oh, that's all right. You're so much closer than most people get when they get it wrong. It's so much better. I don't mind a couple of letters being changed. Hi Kunal. Hi Aryan. Hi Gaming Star. Hello Krish. I see so many of y'all returning, and I'm so happy. I'm super excited to do the last session today. It's going to be a very chill session. Y'all have already done the hard work. I don't know how many of y'all have read the PSP32 data sheet, but don't worry if you haven't, we'll go over it together. Hi, Shamam. Oh yeah, that's possible. So I'm out of my usual location. I tried rescheduling the stream, but I couldn't. So till the time y'all can hear me fine and y'all can see my screen share very good. If you don't see me, that's okay. It's possible that I have a laggy video. It could be a laggy video, yes, in case if y'all can hear me fine, I'm not concerned. Could be either. But if y'all can, yes, I'm on public Wi-Fi. Yeah, if you can hear me and once I share my screen, if you can see my screen share properly, we're good. I have three more streams actually. Tomorrow we have a 1 hour of fun Chrome Dino. So I'll be back in my original place, so we should be good to go then. Okay, perfect. If y'all can hear me, we're good to go. All right, folks, how are we doing? How was day three? Which was your favorite stream in day three? Tell me, you know, tell me what you liked, what you didn't. I do have a backup Wi-Fi. If it gets too bad, let me know. I'll quickly switch and we'll see how that goes, all right? Also, my camera does this AI thing where it keeps focusing in and out, so that makes it much worse. All right, folks, tell me, how was day three? Did you all enjoy it? Which was your favorite stream? Before we get started, if you all are new here, tell me about yourselves. How did you get here? How are you enjoying GHW? Or I'm so every mini event, from what I remember, happens twice. I'm sure there's another Wikipedia races that you can attend. So here's the thing, right? When I conduct mini events, I invite you all onto the stream. So tomorrow, be ready with your cameras and mics because tomorrow we'll play Chrome Dino together on the stream, and I'll send out stream invite links, and you all can come on this stream, share your screens, and then we'll play together. Best of luck, Krish. I know. Trust me, I tried to make my stream earlier because I thought, hey, morning's free. Yeah, the thing is I don't use this camera if I'm not outside, so really no point like working hard on it right now. Awesome, folks. It's the first stream of day three. All right, then how was your day two? Oh, I'm so sorry. Chrome Dino it is for you, Gaming Skull, don't worry. All right, folks. Here's what we're going to be doing today. We're going to do a quick recap of the past two streams. If there are any questions regarding them, I'm happy to address them, especially if there are new questions. And of course, we'll go with the PPT. If you're here for the first time, welcome. I'll give you a quick introduction regardless of you being new or not, because these streams are recorded, and if someone is watching in the future, they want to start from scratch. And yeah, we'll do a quick recap. We'll do a nice little exercise as we usually do, where you all will post something in Discord, and we'll go on to the fun part today. So we're going to go over some protocols, but this is going to be, like I thought I usually do a PPT on protocols. And it's very superficial anyway, because I haven't worked with all the protocols myself. I've worked with a couple, and I'm just telling you that they exist for the most part. So we'll just look at them together. I'll be searching about it. We'll read about it together. The protocols I have worked with, however, are some of the nice ones that, nice in the sense they're commonly implemented and they're easy to find on the internet. So we will actually implement that on Bookweed. And then once we do implement the example, we will do the designing part that I spent so much time on yesterday. Basically, we'll put a couple of constraints, and then based on that, you all can pick different problems and design solutions based on that. Okay. And then, if you all want, you all can actually properly implement the solution, or well, it's still something. I don't know if Shamari has joined or not. Shamari was going to uh, follow along on her physical hardware that she won with the MongoDB challenge. So if she's here, she can also share pictures of her hardware once she's done using that. You did? How was the hack planner? I know Stephen does amazing streams. Alright, folks, I'm gonna quickly go to the PPT and start sharing my screen. Okay. Okay, folks, this is a good time for me to remind you all that if you all have any questions from the past streams, I know one of you all wanted me to explain ADC again. If you all want me to explain ADC again, let me know. If you all want to go over a certain circuit design again or something that we did in the circuit design that did not make sense, yesterday's code, why it wasn't working, what we did to make it work, if you want me to cover that or anything we do today, right? Go ahead, interrupt me, and we'll be fine. We'll cover it, and we'd have a lot of time ahead to kind of make up. Today's a very chill stream, as I told you. We'll be following an example. You really don't have to write anything as much as understand. Okay? And coming back to homework, how many of you all read the ESP32 data sheet? Did anyone see data sheet for ESP32? That's okay. We'll go over together. Don't worry about that. Don't say that. We'll go over together. You'll see a lot of it is very irrelevant until and unless you're, actually using that. Okay, so let's do that. Let's go to the recap, then go read the ESP32 data sheet because that's what we're going to be using today. And quickly get on. Yeah, so let me share my screen very quickly. Share screen. All right, we're back with my favorite theme, the recipes theme in Google Slides. That's awesome, gaming style. I'm so glad you understood so much of it. It is long. I know it's long, but that's how powerful a tiny microcontroller is, Anywho, let's dive right in. Today is IoT part 3. Uh, I already gone over this, I'm not gonna repeat it. So let's just get here. Hi, anyone who's joining us for the first time. Also, the people who know me, you already know my introduction, so I'm not gonna waste a lot of time here. I'm a maker. I've been a coach at MNH for almost 2 years now, and yeah, it is surreal, but I'm so glad to be a part of this community. Also, congratulations to the top 50. If there's anyone here from top 50, I am so proud of y'all, and I'm sure if y'all applied this year and couldn't get through, don't worry about it. I'm sure y'all will next year. This is a good time to, start putting in that tad bit extra effort. Anyway, this is my favorite picture of this slide. I have no clue why. I just love the spices and the fruits. I am so sorry, Krish. Next time. You have a lot of time, to be fair, Krish. Oh, Nisarg did. That is so cool. I will reach out to Nisarg. A couple of hackers reached out to me who, attend my hackathons regularly, and I was so proud. Uh, awesome. Let's move on. And we are live. So, okay, here's what I want you to do, right? If you all read the data sheet, put the part you understood the most. If you never opened the data sheet, open the data sheet now for ESP32 and post the most confusing thing that makes absolutely no sense to you. Can you all do that? Absolutely, Aryan. I'm completely rooting for you. Next year. Again, rooting for you too, Krish. Alright, folks. Come on, I am on Discord. I'm waiting for y'all to go find the data sheet. If y'all can't find the data sheet, let me know. And post if you read the data sheet, your favorite part, the part that you liked the most. And if you never open the data sheet and look at the word that makes absolutely no sense, or the sentence in the first 5 pages. Let me make it much easier for you. In the first 5 pages, the easiest basically uh, task here is they whatever you find super confusing, like a word or and take a screenshot and put it in Discord. Come on. I know y'all are fast. I'm waiting on Discord to see screenshots of data sheets. I know Gaming Skull read it. I know Aryan couldn't understand it. So Aryan, whatever you did understand, right? We discussed ADC, we discussed protocols and interfaces like SPI. So just open it, see what you did, remember, what you kind of felt familiar with, and tell me. Congratulations, Nisarg. I heard you got top 50. I'm assuming you're the same Nisarg that I met and that attends the hackathons. All right, post that picture, post that, section from the data sheet onto Discord. Awesome. This Gaming Skull did too posted. That's amazing. Thank you, Gaming Skull. All right. Is anyone else posting? Aryan, Krish, Kunal. Just open the data sheet. Pick up a section you feel familiar with or find absolutely confusing. Mm, that is amazing, Nisar. Gratitude is always an amazing thing to, follow and practice. So super proud of you. Yes, a virtual party. Folks, I really want to chat with y'all. I really want to have fun, but we'll do that tomorrow. Let's get through with the IoT taxi, and tomorrow we'll have an hour of just, mindless chatting and fun. Yes, then y'all can come on the stream and just chat how much ever you want. I like how you're still planning the party. No one else is posting the data sheet. Hi, Anuva. Are you joining the stream for the first time, Anuva? That's okay, Anuva. We'll be doing a recap soon. That is awesome. You already found out what it is. It's okay, Anuva. You'll catch up in no time. I'm sure. Sure. If you're here, you're smart enough to already know a lot of things. So I am rooting for you again. Why not? Why would it do our automotive interface not be in ESP32? Okay, no one else is posting pictures from the data sheet. No one else wants to read the data sheet. All right. Absolutely, Anua. We'll be doing that in just a minute. Okay. I'm a tad bit disappointed in y'all because I know y'all are interactive and I know y'all have opened the data sheets, but that's okay. I'll be going over the data sheet anyway because we need to know what's happening when we do the coding part. But Oh, don't worry, don't apologize. We'll recap. And Nisarg, I know you've attended a lot of my other sessions, so I'm pretty sure you're up to speed anyway. Okay, that's an interesting take. Let's look into it and we'll see whether or not. Yes, I am aware of that. I'm so sorry. It's okay if you can't see me. Just listen to me and watch the screen. All right, folks. Let's dive into the recap since none of y'all are posting your datasheet pictures. So let's recap. All right, what did we learn? The most important thing that we've learned in the last two sessions is how do you know a device or a system is IoT? And you've learned a lot more electronics than you've learned IoT per se. You've learned how to connect your device and get it up and running, right? With actuator and with an LED, right? So basically consider an LED an actuator. And in the end, you can write that actuator code to anything, whether it's an LED or a motor. So what we'll do is we'll go back to the circuit and instead of the LED, put a motor. Then you'll be able to adjust the motor speed as per the uh, potentiometer value. All right. And it's fun. So we know how to connect a circuit. Now the only thing remaining for us to do is put it on the network, right? Put it on the network and get it to communicate over the network, right? So that's what we'll be doing today. But quickly, what the most important definition we studied in the first and but to the most extent in the second section is what is IoT? IoT is human independent communication, right? What do you mean by human independent communication? Yes, a TV remote sending a signal. Possibly. I hope that's it. Right? Okay. So, human independent communication. It's not just human independent that's the important part here. Here's the communication part that's much more important, right? So, how do you know it's communication and it's human independent machine? Well, first, it will have layers, right? How do I mean layers? I never discussed this in detail, so let's do it right now, right? A device has multiple layers and multiple ways to get on the network, okay? Get on the network and communicate, right? So it can get on one network and communicate in multiple ways. It can get on a completely different layer, then connect to a different communication protocol, and hence get on the network in a very different way. I know it sounds a tad bit confusing, but I'm gonna explain it in more detail in just a second. New season stickers. I'm not sure what stickers. Oh, the you mean the graphics? I think they should be available on the either the Swift keynote or the opening ceremony. That is great, Krish. Oh, by the way, where's Tinden? I actually asked Mary and I can do a swag drop today, so I will be doing a swag drop today. So yeah, stick around till the end if you all want to participate in the swag drop. All right, I don't see a lot of excitement about this swag drop just yet, so I'll keep going, right? So it has layers. Okay, so what do I mean by layers? Wi-Fi, Bluetooth are different ways of getting connected, or rather communicating, right? And HTTP request is a one way of communicating. Now, they're all different things, right? Now, when you say Wi-Fi or when you say the, Wi-Fi network connection, it's happening over a particular layer in your entire device structure. When you talk about Bluetooth, it's a different layer altogether. It's a different layer of the device that is, providing and facilitating that communication interface, right? So that is what I mean by layers. So a device which has, for example, yesterday we spoke about and we came across the word SPI, I2C. Those are also different layer interfaces which are helping you communicate between devices, right? So a device connected to a sensor directly via a wire, okay, is can be connected over a certain protocol. One of the easiest protocols and one of the most common protocols actually is UART, right? You must have heard of UART at some point. Now, this is also a communication interface, right? How is it different from IoT, however, is when it's doing it wirelessly, right? So that's another requirement for a system and a device to be IoT, right? Or we'll look into the protocol and the layer situation again if you all have questions. in case y'all don't. Very smart, but I hope you all do because this can be a tad bit complex. It's not complicated, it's just complex. We just need to break it down more, right? Okay, so an IoT consists of I'm doing this for the people who are joining here for the first time or missed the first two streams. So just stick around until then, and then you can just follow me when at your own pace, right? Um, that is an amazing question, Gaming Skull. I love that question. I'll take that in a good amount of detail in just a second. All right. So, next, how do you break down an IoT component? There's hardware, there's RTOS, there's human independent decision making. Right. There's some algorithm that is deciding, okay, what do I do with this information? Right. There is an acknowledgement. Now, when I say there's a communication happening, it is supposed to be, you know, a given. It's supposed to be obvious that one person or one device has said something and the other has listened and the other device knows whether or not it was listened, whether or not it would follow the command, so on and so forth, right? So there's always an acknowledgement, whether it's an error message that hey, this couldn't happen, whether it's a timeout that hey, I couldn't really reach the other device. There is always an acknowledgement and there's a flow after that acknowledgement is received. Make sense? All right, so that is your basic definition of IoT. So if you look at a system, if you look at a device, right? One, you can decide whether or not it's capable of being an IoT device. Second, by looking at how it's communicating, you can decide whether or not it's part of an IoT system in that given moment. Make sense, folks? If you all want examples, I can give examples, but we don't really want to, waste time here. We want to go on to the part we want to do today, right? So just a quick recap of the architecture. These are the, architectures of IoT. I'm not going to explain this today. If you all want a detailed explanation, you can go back to the past streams or ask me current questions right now. Yeah, you know what? If the video gets any worse, let me know. I'll try and switch Wi-Fi. Yeah, but no promises. And if it's too distracting, I'll just remove the thing altogether. All right, folks, this is better. Can you all focus better now? All right, great. So looking forward, that's a play on the word. I am not absolutely, Aryan. Let me explain firmware to you. Hi, Hemang. Welcome to the stream. Perfect. I'm glad you are happy about this. I got more response on removing my video than I did for the data sheet. Folks, I suggest you start reading and sharing something from the data sheet if you all want to participate in the Slack drop. All right, folks, let me explain to you what is firmware, right? So, firmware, can you believe that it's actually firmware because it's software that goes onto hardware. So it's, software is basically completely, virtual and on basically all code. Hardware is completely basically, components and devices. Firmware is the middle point, right? The software that goes onto the hardware. Hence, it's called firm. And I'm not kidding. That's actually why it's called firmware. So soft, firm, hard. That's why it's called firmware. But firmware is basically any code that goes onto your embedded system, right? For example, your TV, your washing machine, your microwave, whatever code that's running on the chip, however simple or complicated, smart or dumb, it is called a firmware. Make sense? So if you all ever go into your menu of either a printer or microwave, there'll be a firmware upgrade or a firmware update option. That is basically the software that's running on your hardware. Make sense, Aryan? Absolutely, Shivam. Let me pull the data sheet. I'll share it with everyone once we get to it. But until then, oh, thank you so much, Gaming Skull. There you go. Perfect. This is the link that you can follow. All right, folks. So cool. Now you know what's firmware. Device architecture. We discussed a little bit of device architecture yesterday. Does anyone want to tell me what device architecture is? No one? We discussed device architecture yesterday. Come on, folks, I expect better answers from you. Is that the answer, gaming style, for device architectures? The basic hardware elements? Okay, so device architecture is basically, so initially, imagine it's like basically why there's Windows, Mac, and Linux, right? You came up with something originally, and then you came up with a different way to do it based on the purpose you wanted, and you kept evolving it, right? So every time Intel has a new chip or AMD has a new chip, and there's different device architectures like x86, x64, it's basically evolving and solving the current problem. And then when you solve that problem, you realize there are other problems that can be solved by it, and you general purpose it. So that's how device architectures vary. All right, there are some of the common architectures out there are AVR, Extensa, and ARM. All right, so ARM is one of the most common architectures. Common in the sense it's very widely used. Sure, you can call it that. That is also something that differs. But yeah, basically, right? So your timers and everything, but mainly how you define an architecture is based on a couple of basic things like its addressing system, its compiler, how the code gets uploaded to it. It becomes a family of hardware basically that you can do a lot of things on commonly. And yeah, so if you can, so when we were using Uno, we were using Atmega 328P, which is basically your AVR microcontroller. Today we'll be using Extensa architecture when we use ESP32. Exactly. So ARM and x86 are for laptops and computers. For microcontrollers, there's AVR, ARM, and Extensa. And there are a few more, like RISC-V is a new architecture out there, which is gaining a lot of popularity. And again, you don't have to concern yourself with the details just yet, but if you do get interested and read about it, definitely go for it. All right, let's move on. Okay, protocols, right? So we'll look into some protocols. Like I'll literally share my screen, we'll read about what protocols are. But before we do, right? Before we do, let's, can you all tell me, can you all try to guess? I'm going to give you all exactly 2 minutes. It's 4:03 in my clock. Until 4:05, I'm waiting for you all to tell me what could a protocol possibly mean. All right, awesome. Rules. That is amazing. That is a great answer, Aryan. Way of communication with client and server. Set of rules. Great. I have another minute for you all to answer. So if anyone else wants to take a shot at it. But that's what we're talking about, gaming skull. We are talking protocols in the sense of communication. Guidelines, that's a great answer. That is an amazing answer, Roshan. And welcome back to the stream, Roshan. Specific set of rules that both parties need to communicate with each other. Perfect. A way to send and receive data. That's a great answer. Well, yes, the point of this exercise is to, kind of get you to still tell me the generic definition and then build up to the basic uh, IoT protocols. All right, any other answers anyone else want to answer? No one? Okay, so here's what I'm going to do. I am going to go back in this mode, not this mode, this mode. And now what I do is I stop sharing my screen and we'll go to Google and look up what protocols really are. Right? Okay. So we'll be reading about it together. So next time you want to find your way around things like this, you all know how to find information. Right? So let me quickly present my screen. Let me just pull a new window out. Present, share screen, window, new tab. That is an amazing answer, Gaming Skull. Translation layer. Great. I love. I know you basically know the answer at this point, but I love the other answers that we've received also. Right? So, what is finally protocols? Let's look them up. So, IoT protocols. There you go. All right, let's. Wow, I love what Google has done for us. It's made. Oh, yeah. No, I didn't want you to Google IoT protocols. I was just asking the general meaning that you think what protocol mean, right? You did not have to be correct. You did not have to know the answer. Yes, you can, but I don't want you to know the right answer. Remember, we do an intuition exercise before we actually dive into a definition. It's to make sure that you all remember it well, right? But it's okay. Yes, you can always Google with me. With me, it's always open book, right? So you see so many protocols out there. There's MQTT, there's Zigbee, there's advanced message queuing, which is AMQTT, and Wi-Fi, constrained, co-op. This is what also I was talking about. Then there's LoRaWAN. There was also LoRa at some point. There's Z-Wave. LoRa's right here. There's LTE-M. There is LWM2M, NFC, WebSocket. So many of these you've heard, right? I mean, HTTP is one of the most common protocols out there, right? So why do we need so many protocols? Can anyone tell? Why do we need so many protocols? It's not about killing creativity. I don't mind you all Googling, but the whole point of that exercise is to, have fun. Mm, Hi there, Justle Time. That's an interesting username. Different solutions for different protocols, but what is the need for different protocols? I mean, after all, we're just communicating, right? Okay, yes, to some extent to get the idea of what's happening, but if you're getting you want that in every protocol, right? You do not want anything to just happen and you have no clue. The whole point of communication is to get good acknowledgement, right? Yes, different things. They need to do different things, exactly. But how different? They're finally communicating, right? What is it that they could be doing differently? I already spoke about one of the things in an earlier slide today. So what are they doing differently? Come on, folks. I know you know the answer to this. Amazing answer, Kunal. Yes, that you're getting close to the answer. So Bluetooth is short range and Wi-Fi is large range. Okay, so the range problem is solved. Why do you still need so many protocols? That is correct. Every protocol has different ways of communication to provide feedback, some fast and some support two-way. Every communication has to be two-way. What do you mean by two-way? Sorry, folks, I went on mute and did not realize. Uh, that is an amazing answer, Shivam. Maybe different devices have different protocols. That's a good answer. Why would different devices have different protocols? I'm sorry, I don't want to annoy you all, but I really think you all know the answer. I just need to push you all into getting it. Okay, wireless. That's you need that to be that is you're getting much closer, Nisarg. Okay, folks, I'm gonna give you all the answer. All right. So the simple answer here is there are 100 constraints when you're designing IoT solutions, right? From the first thing that you want to always consider is, of course, range. How far are you sending the signal, right? That's one of the first constraints. Second, remember there's also the cost constraint, right? What if you have a, for example, LoRa and LoRaWAN, right? They send real long distance signals. But if it's too expensive, right, you'd rather, and it's the same cost as putting three routers, and you have, the power to, get three routers, you'd rather get three routers and use Wi-Fi, right? So there's the cost constraint. Then there's the hardware constraint. Then there is, where are you located? How much data can you send? For example, one of my favorite stories is about the MQTT protocol, right? So do you know how MQTT protocol came to be? It's one of my favorite stories. So you see this, the history, and if you read the history of every protocol, it is super interesting. But this is one of my favorites, right? So like Andy Clark and Arian Ripper authored the first version of protocol in 1999. So they were actually working on an oil pipeline which was located in a desert, and because there were basically literally nothing to send data over, they had to send absolutely optimized data over really long distances, right? So they had to come up with a protocol that did absolutely no wasteful communication, right? It told you what it wanted, what it was doing, and the message in like basically one data packet, right? So they came up with MQTT, right? And that's how a new protocol was born, because when they were designing their IoT solution, there was nothing that fit their need, and they designed their own protocol. Tomorrow, let's say if you come across a problem that you need to solve, and There's absolutely nothing that fits the bill. You're going to have to be creative and come up with something yourself. And you might, invent the next protocol. But the whole point of protocol is we spoke about different architectures. We spoke about different, ways to code. So you can use one device that's using Python, one that's using C, and basically everything can be communicating on different ways on a different architecture. How do they communicate amongst themselves? Right? That is where protocol comes into being. So it basically means, how different companies have protocols of, fire safety, emergencies. Why? It doesn't matter what language you speak, it doesn't matter where you're located in the world. The protocol remains the same. So it's easy for everyone to coordinate and follow and communicate. That's exactly what the devices are doing, right? No matter what language they're running, what language the code has been coded in for that matter. They both are listening and communicating with the same bytes and are expecting the same bytes, hence they can communicate. So obviously you can't send an MQTT message to a Bluetooth device or a co-op device. Both the devices need to be running the same protocol, should be expecting the same protocol to be able to communicate. Remember, communication is not one way, it's always a signal and an acknowledgement, right? Everyone on the same page? Awesome. So that is basically what protocols are. The thing is, I used to do this very advanced thing where I used to go over some of these because most of them have pretty good stories, right? For example, Zigbee is a protocol that was actually came into being because the people were actually observing how bees communicate. And that's how Zigbee came to be. And when you start reading about these, for example, LoRaWAN is the protocol, right, that can send signals like for kilometers, right? But there are different constraints for LoRaWAN. And obviously, if it's sending a kilometer wide signal, it's also consuming a lot of power. So if you have a battery operated device, or if you have a device that you do not want to change the battery off or charge in a really long time, you might not want to use LoRaWAN. Or you might want to give it high powered batteries. For example, if you're keeping a tracker in the jungle, while you can keep a heavy battery, remember you're endangering any animal or anything that comes nearby, right? So there are a lot of things that you have to think about, and we'll do that when we start solutioning our own basically IoT system in a while, right? That's a great question. So MQTT was one of the first versions, right? They did not require a lot of security the first time they created MQTT. So if you look up MQTT, there are so many versions of MQTT now, and there is something called quality of service. Basically, quality of service decides how encrypted and how secure that data packet is. So we'll look at the data packet in a bit for MQTT because that's what we're going to be implementing today. It will be running an example basically, but that's good enough for you to, catch up, right? So basically, changing the structure of the packet, you can change how it's communicating, but a very basic answer to your the question, Gaming Skull, it's a version of the protocol. It's a certain version of the protocol. And obviously, think about it, right? If you have so many devices around you, you do not want them to confuse messages, right? So there's always going to be a certain layer of encryption or proprietorship that you'll add to your device, no matter how open source the protocol is or how, common the data layer is, right? You want to add one little bit of, proprietorship or an extra layer of encryption that only your devices understand, and they don't take a random message or they don't give out and send other devices random messages. There is so much in the chat, and it's just hard for me to keep up, but you all get the point, right? I'm not sure if it is IoT. If it's transmitting wirelessly, then maybe. But if it's connected via wire, then it's not IoT. All right, folks, let's go back to our presentation now. So go ahead, read about other protocols. If you all have questions, you can ask me. I've used some 4 or 5 protocols, but I'm happy to implement more if you all are actually trying it. PPT is right here. Awesome. So let me pull this up. Cool. So we did protocols. Okay. So what we'll be using today I wanted to teach you all Zephyr, but I won't be able to do that. So I am going to quickly send you a tutorial link, which if you can follow, I promise you it will do you so much good. So Zephyr is an RTOS. If you all missed the RTOS explanation, please go back to the other streams because I do not want to spend more time explaining past stream things. But I'm sure you all are smart enough to catch up in like, 5-10 minutes once you go through the stream, right? So Zephyr, I won't be able to cover. But if you all like it and you follow the tutorials, we can have like an entire track on Zephyr next time. Okay? All right, so we're gonna look into MQTT. We already looked into the other protocols. I'm not gonna cover it at all for that matter. But if you all want and if you all have questions about certain protocols, we have two more streams in this GHW technical streams, and you all can come ask me questions before or after. All right, awesome. So this is the link that I just shared in case you all did not see it. Go over it. It's a genuinely good. You'd learn so much about embedded systems in and out. All right, awesome. Give me. Okay, there we go. Let's go on to the next thing. Okay, this is the MQTT architecture. So before we get started with the MQTT architecture, I want you all to go over the data sheet of ESP32, right? So consider this a break and like 5 minutes to read your data sheet. So that sounds very interesting. Gaming let's go ahead and share the link to that. All right, folks. So before we get into MQTT, I really want you all to go over the data sheet of ESP32 once. So I'm going to give you all like it's 4:20 on my clock. 4:30, I will be back. So you all can take like a 5 minute breather. And I want you all to read the ESP32 data sheet. And we'll reconvene here in 7-ish minutes. We read the AtMega one yesterday. Today you want to read the ESP32 one. So search ESP32. That's what we'll be using today on Wokme as well. Thank you, Gaming Scars. I'm sure this will be very interesting. I'll watch it too later. All right, folks. So we'll be back in 7-ish minutes. All right, folks, how's the datasheet reading coming along? Hi, Shamali, welcome back to the screen. Good advice. It's a good time to stay hydrated if you're taking a break. That is very cool, Gaming Skull. Do you want to share a picture of what you built on Discord? Alright, folks, seems like you're having a very interesting discussion here. But did you all read the datasheet? That's all right. That's the whole point. See, y'all are, that's how you learn about a lot of things. And now that we'll do the actual example code, it'll be a lot of fun. Because you have certain idea, you know, y'all, especially if I use some word, you all will know where to go and look for it. Only understand the application part. All right. Awesome. So let me quickly now share my screen to the ESP32 datasheet. And then we can look at it together very quickly. Go with the ESP32 datasheet. Or are you all comfortable with it? Do you all want to go over the ESP32 datasheet or not? You know what? Let's go to Workbee first. Let's go to Workbee, and I don't know if you all have signed up already or not. So let me share this tab. Can you all see Workbee on the screen? Okay, so I need you all to go to Workbee and sign up. So I'm going to give you all a minute to sign up on Workbee. Let me know once you're done signing up. Awesome, you all have done that already. That's smart. Awesome, so let's get going then. What we're going to be doing is we're going to be doing a very simple thing, right? Uh, Once you're on Workbee, I want you all to open a random ESP32 example. So let's say ESP32 plus DHT22 sensor, right? Open this, understand what's happening here, look at how the pin is being addressed, how the connections are being made, simulate the code, look at the serial data, how it's coming, what it's printing, right? And yeah, I'm going to give you all exactly 3 minutes to do that. 3 minutes, run a random ESP32 example. You do not need to run the same example I ran. Just look through it. It does not have to be even an Arduino example. Just understand what are the tiny differences between when you were using an Uno R3 and versus an ESP32. All right? Oh, absolutely. Let me send you a link to workwe.com. Here you go. There you go. Here's the link to the Workwe software. Alright, folks, so just run one example, and if you want, go ahead and run a Nuno R3 example also, and just observe, right? Observe what's happening, observe what's different, what you think needs to change, alright? And if you all just play around with it, and if you all feel very confident, go ahead, create a new project, add an ESP32 and blink an LED, like we did the first day, right? Basically, or just turn on an LED, right? Digital write to one of the pins. And how will you find the pin number? Look up ESP32 pinout. All right. So what will you do? Let's say you take a new project. So my projects. These are all the ones that we did. I click on new project. I click on ESP32S2. Doesn't matter which one you take. All right. So now I have this. What I'll do is I will go on a new tab. I'll pick ESP32 pinout because I don't want the entire data feed just yet, right? I just want ESP32 pinout. And now I know my model is ESP32S2. So I want ESP32S2 pinout. And just click on a random image and understand what the GPIO structure looks like. All right. Usually the website that I love for this is Random Node Tutorials. So if you find that, yeah, there you go, right? Random Node Tutorials has ESP32 pretty well documented. So you just come here, look at this, okay, and figure out the pin number, right? So let's say you want to connect it to GPIO 35, which is pin 11. So go back to your workflow, the new project that you created, and over here, you basically zoom in, go to pin number 11, right? And you want to go here, you want an LED and connect it to an LED. Remember, the anode is the positive end, and then you just want to connect it to ground. See where is ground? This G is ground. And now write the code to basically turn this LED on. That is it. Think you can do that, folks? Sure, you can. Go for it. Use the delay. You can also use a time interrupt. So that is the answer to your question, by the way, gaming scholars. There is something called a timer interrupt, right? So time interrupt is basically you telling the code every 5 seconds, forget everything and do this, right? That's a time interrupt. And if you want multiple time interrupts, you want multiple timers. Make sense? So the LED is in the components right here. All right. So I'm going to shut up for the next 5 minutes and I just want you to focus and just make the LED blink or just run an example if you're not confident about the LED just yet. Or open an example, modify the pin numbers, see what's happening. And I'll also send you the data sheet, rather the random node tutorial link that I usually follow for pinout, and you can use that. Sure, that uses it too, which is why you have multiple timers and you can allocate multiple timers. You can also have a timer interrupt that, so you can also optimize the timer, right? So what you can do is there's something called timer overflow and timer, so basically if you create a pulse, whether you want on the rising wave or the, rising down wave, basically, all of those things you can do. So in a single timer, you can have a lot of things happening, but it's always easier if you have multiple timers. So the more sophisticated the board gets, the more timers it has. So you can have like 8 timers, 6 timers in some boards. All right, folks, I'm going to go off screen and like absolutely basically not exist for 5 minutes. And I want you all to just try one example or modify the example. And if you feel very confident, go ahead, create a new one and just, blink an LED if you can. No, basic, no pressure, right? We'll do it together once I'm back. So 5 minutes, it's all you. Have fun with it. Don't stress too much. All right, folks, how's it going? Did you blink an LED? Did you modify an application or an example? I see you're having fun with the data sheet finally, Gaming Skull. You're actually genuinely enjoying the timer verse, huh? You shared it also? Let me have a look. Oh, that is so cool, Aryan. Hey, I want dark mode. Why don't I have dark mode? Let me let me go and see why I don't have dark mode. I'm pretty sure I had at some point. Oh, I want dark mode. I can't figure out. Okay. Anyway, I'll figure out the dark mode later, but it's very cool, Aryan. I'm so glad you got it to work. Um, just by the way, Aryan, you haven't gotten the LED to, you haven't digital written a pin. You've just connected it to 5-volt supply. No worries, Shamari. I actually added you in the agenda today. I'll show you later. All right, folks. I'm gonna wait another minute. Is anyone still trying? Is anyone still playing around with an example of ESP32? Awesome, Kunal. We're waiting for you. Don't worry. Kunal, are you done? We're waiting for you. I like how you all are so sleepy right in the middle of the day, or rather evenings. I guess that's fair. All right, is there anyone still trying? Are you done? I'm waiting for anyone who's still trying to do the thing. All right, so here's this swag drop challenge, right? Anyone who wants to enter the swag drop will be following the MQTT thing that we're going to do now. So let me see Kunal's. Okay, Kunal, great job. Great job. You've done it very well, except analog write is not high or low. Analog write is a PWM, right? So you'll give a value from 0 to 255. Digital write is a high or a low. Makes sense? So digital you give 1 or 0, so high or low. And analog, if you're doing analog write, you give a value from 0 to 255. Also, in ESP32, you cannot do an analog write, just by the way. I don't know if Vokvi is not giving you a compile error, but you cannot do an analog write in ESP32 because it does not have a PWM channel. What you do to, give it a PWM value is you write a high and a low, and you actually give it a delay to control the brightness. It's actually very cool. Great job, bud. Great job, Aryan and Kunal. Giant potentiometer, awesome. I like how y'all are playing with it now by yourself. Amazing. But stop right there. I want her to continue doing this. What we do want to look into it is MQTT, right? That's our main goal today. So let's go back to our tab. Now y'all are slightly more comfortable with ESP32 as a controller. Y'all understand the basic stuff is the same, right? Y'all can write to the pins, y'all can read the pins, and you set a baud rate if you want to print something on this serial monitor, right? So great job. Now what we want to look into is the protocol that we'll be using. So why do I like MQTT so much, right? MQTT is one of the simplest and the most optimized protocols for a very, uh, there's no drama when it comes to communication, right? Everyone is talking to everyone, everyone listens, everyone writes, and there's no, roles. The publisher can also be the listener, the broker can also be the publisher. everything happens with everyone. Everyone can be anything basically, right? So you see the structure. Yeah. What does happen is where you're sending the packet, right? So there's something called topics. What you do is you have a very simple, almost like a URL. You get connected to the local network and you basically publish to that network. Okay. Anyone on the same network, or if they go to that, basically URL, they can listen to the message, right? Now, what happens is it does not store all the messages that you send. It only saves the last message that you send until a new message comes. So let's say the publisher sent a certain temperature, right? And the broker listened and published it. Now, if a new subscriber comes, it will send the last published message and then it'll send the new message. Nothing past that is available to the new subscriber. All right, it's a very simple protocol. And what do I mean by the packet? Right, I said there's a data packet that's getting sent. Right, so this is the data packet that gets sent. Right, so you can see it's very optimized. It's very basically no drama. It's to the point. It's telling exactly what it needs. The other controller needs to know to get the message. Right. So first you have the control field. What's the control field? It's basically, what am I doing? Do I want to keep the connection? Is it so? What happens is you send multiple data packets. One is the connection package, then you send the message, whether you want to keep the connection alive or not, all of that you basically send. Okay, then there is the remaining length, which is basically kind of a checkpoint. Now you want to listen for 11 more uh, data bytes, right? Then is the length of the actual thing, of the message. Okay, so the length of the message. Then is the protocol name, right? So MQTT and the protocol level, because now there are multiple protocol levels, so you want to make sure that both the devices are listening to the right protocol level. Then comes the connect flag byte. Remember, we spoke about the control field and the connect flag byte. So now, then whether you want to keep it alive or not, do you want the connection to be like an instant connection, get the message and remove the connection? Or do you want to keep listening, right? Why do you want to not keep listening? Because your power is going to get consumed if you're continuously listening, right? So your connection can also be very to the point only when you need it, right? So if you're sending like one message a day, you do not want to keep it connected. Then is the length of the actual message that you're sending. This was just telling the other device, okay, this is the protocol. This is how I'm going to be talking. Then is the actual payload, right? So the now, here's the fun part, right? How do you maintain security? If anyone subscribes to this, right, on the network, they can listen to it, right? So where does the security aspect come in? Well, there's something called quality of service. So you see the control field, that will kind of control the quality of service. If it's 0, it's quality of service 0, basically no encryption. If it's 1, then there'll be some user key and some password being encrypted. And as we go through the level, the encryption level and the way the communication uh, complexity increases, and hence the layer gets more encrypted. Fair? People on the same page? Everyone on the same page? Does this make sense? No, this is too confusing. I don't get your question. A bit is good. Basically, when you, so let's say very simply, right? Let's say you do not want to use any library. You literally go and make a data packet and send byte by byte over the internet, like over the network, and the other device will listen and actually acknowledge. No worries, Shamari, you can get back to me whenever you do try it and have questions. So you don't understand the connect flag? So basically, the connect flag is saying that, okay, connect me. The keep alive flag is basically telling the connection, okay, keep listening or keep publishing or keep, basically keep stay on the network and keep the connection alive until I ask you to, fade, or if there's a timeout. One of the two happens first. Make sense? If you say that no, the keep alive flag is not there, then what happens is you connect, you get the message, basically the message is sent, and the connection is not maintained. Does that make sense, Aryan? All right, awesome. So you all can read about it in more detail, and once you start coding it and start looking into the MQTT library, it'll make way more sense. All right. Awesome. So that's MQTT for you all. Just enough for you all to know. Uh, Ideally, I would love to sit down and break down the entire concept of how MQTT works, and actually show you how you can actually write code from scratch to send MQTT. You do not need any libraries. You can actually entirely encode the thing yourself. But we do not have time for that today. So let's go back to Wokwi, right? So let's go back to our original Wokwi page. So share this tab instead. I hope you all can see my Wokwi now. Perfect. So I do not know SHA block what you're talking about exactly, but every protocol, remember, has a specific reason that it was created, right? So it's optimized for something specific. Now it can be not be used very commonly because it was very specific to the use case, or it can be used commonly like MQTT because it just makes sense. It's too optimized for anyone to care that it's using lesser bandwidth than they have. Because if they have more resources and they're using less resources, that's always good, right? So right? So, but I will look into it, gaming skull for sure. All right, awesome. So what I'm going to do here is I'm going to go into featured IoT projects and I'm going to look at MicroPython MQTT weather logger, right? Let's open this and let's go with the code that's happening, right? And they have given such nice instructions here, which we'll also follow, right? But let's go with the code ones, right? So first we have import network because obviously we're using a network layer, right? Then we have import time because we're going to give a delay, we're going to make it wait. So we want a time library that's controlling. So you can also do it without the library. You can always, so everything that's happening here, right? Any library that you use, you don't always need a library. You can actually write the entire code yourself if you're just using a tiny function. And if you know and you've read the data sheet of the network or of the component well enough, all right? So if you ever get a chance or if you're ever really interested, open the library and see what's happening on the hardware level. What register is it talking to? All right. But basically, having a library, you can just use simple one-line commands and make your code look better. It's obviously a much bigger code in terms of footprint. But if you have a lot of space and you're doing it from a hobby perspective, it makes sense to save time, right? So all right, so import time, right? Then you have import DHT. You have import JSON because you want JSON to be easily manipulatable. And then you have from mqtt.simple your MQTT client. All right, cool. So the client is basically going to be publishing. So this basically MQTT device, this entire block is going to be publishing data. All right, cool. So then we have our sensor, which has been initialized. So there has to be a sensor library, which we looked at. Awesome. Next, we're going to use, we're going to print and connect to Wi-Fi. So Bokvi has this thing where it has a virtual Wi-Fi. It connects to a virtual Wi-Fi and it does a lot of things, which is very cool, right? You can read about what's actually happening on the documentation. Let me see if I have the documentation open and I can send you the link. Yeah, there we go. It's doing the Wokwi has a very cool channel also where they're actually publishing live videos of how they code these things. Correct. MicroPython is a microcontroller Python language. So Python-based microcontroller RTOS to some extent. All right, folks. Right. So we have that. Next, what we're doing is status if. This is they haven't initialized this anywhere. So they're taking a variable. Oh, it's Python. So it's basically it's going to assume the variable data type, right? So then they're doing if connected network.status. If it's connected, then it will connect to Workvi guest. So it's going to check if it has Wi-Fi. If it has Wi-Fi, then it's going to try and connect to Workvi guest. Till the time it's not connected, it's gonna wait. And once it's connected, it will go out of this while not connected, status not connected, and it will print connected. All right, so this is just the part of it connected using the network library and connecting to the Wi-Fi, the virtual Wi-Fi, right? Next, it's going to connect to the MQTT server, right? How it's going to connect to the MQTT server is using the library. So it has again a data is a variable which has a data type that's being inferred by Python. So client is equal to MQTT client. Then there's client ID and MQTT broker, right? What is the client ID and MQTT broker? Have we specified it? We've specified it here, right? We have our macros here. So our client ID is MicroPython weather demo, and our broker is broker.mqttdashboard.com. Now we'll go here in a bit, right? Our user and password, we do not need it. So basically, if there's a user and password, that means it's QoS 1 or 2, right? We don't care about that right now. All right. Then we have our previous weather, empty variable, right? And then we have print, then we have sensor.measure, which is basically taking this is just the internal communication. There's no network layer involved here except the interface that's giving the sensor data to the microcontroller. Okay. Then once we get the message, we're dumping into a JSON, and the JSON is temperature, sensor.temperature, and there's humidity, which is sensor.humidity. All right. Then we go to message. What we're trying to do here is basically we're trying to say if the message is different from the previous message. That means if the quantity has changed. Instead of comparing the quantity, we're just checking for the entire JSON. We're saying if the last JSON that you dumped is different from the current JSON is different from the last JSON, only then you will publish over the MQTT network. Okay? If there is no change, it's going to do nothing, and it'll just keep printing the same sensor, the same message over and over onto our serial monitor. Got it, everyone? Does the code make sense? Awesome. Gaming Skull understands it. Is there anyone else who has any questions regarding the code on the screen? I am honestly not sure what the machine library here does, which is why I haven't explained, but I'm assuming what it's doing here, it's basically helping ESP32 connect to DHT using the pin numbers, really. That's it. Everyone, same page? Awesome, I see so many yeses. Okay, Kunal understood, Shamaria understood. That's awesome. Aryan understood. Python is always easy. You know what? From next time, we'll just stick to MicroPython then. Okay, I like how you're talking about MicroPython. Go for it. It's a very interesting microcontroller way to program a microcontroller. All right, awesome. So now we understand the code. Before we run it, let's follow the instructions above to be able to see it, right? So it's first asking us to go to hive.mq.com. It's asking us to go to demos/WebSocket client. So we'll do that, right? So let's follow link. There we go. So I'm gonna share my hive.mq. I'm gonna share the link in case you all don't have it. I'm pretty sure if you have opened the sample, you have the link right there, but in case you don't, here you go. Okay, then what we're gonna do is we're gonna click on connect. Just whatever is there, don't play around with anything, just click on connect. In case you're wondering what's happening, so mqtt.dashboard.com, remember when we were basically in our code, we specified what we're connecting to. So we were connecting to mqttdashboard.com. That's the broker we're connecting to. Okay. And the rest of it is given to us. So the port you don't really care about. It's Hive MQ port. You do not want to just, right now do anything here. Okay. So connect, and over here you're gonna add a new subscription topic. So what is the subscription topic that they've asked us to add? They've asked us to add Wokwi weather, right? Let me go and quickly check. Yep, Wokwi weather. So I'm gonna copy paste Wokwi weather. So in case you all aren't sure what I'm doing, I'm here. They're asking us to copy paste Wokwi weather. So over here and share this tab again. So Add new subscription, work weather. That's a work weather. There you go. I'm going to do the QoS down to 0 because I haven't added a user and a password. So it doesn't matter again. Work weather, connected. Great. Now, every time I change something over here in the code, basically, I'm going to go back over here, share this tab, and I'm going to start the simulation now. Okay. Can you all see my tab? It received the message. Now it won't receive any message here until and unless I change the entire thing. But before that, I want to see where you all are. Oh, you see the message. Perfect. Awesome. All of you all see the Hive message changing, right? Now this message won't change until what? The conditions are no change, right? So until and unless this is not changing, you won't see anything there. So what I'm going to do is I'm going to click on my DHT, and you can see that there are two toggle buttons. There are two slide bars, right? So I'm just going to quickly change the temperature. So temperature changed. The temperature changed. Now if I go back and I'll see here, you'll see I have a new message right here. Got it? So when I changed so many temperatures, it's basically got a lot of ranges because of the rate at which it was running. And awesome, right? Exactly. Simple, cool. Isn't this cool, folks? So I'll just literally use the protocol. Now, here's the fun part. Here's more like a homework, okay? Because I really don't want to pester you all because it's the last session and you all have done something really cool, right? So congratulations, you are connected to the MQTT. You all used your first and so basically what you've done is you've done an entire IoT cycle because every time an MQTT message is sent, there's an acknowledgement that's received. So if we go back to our code, you'll see when we're publishing to MQTT, we're basically going to get a client.connect, right? So in that client.connect here, what happens is it sends and then it waits for an acknowledgement. All right. So that's what happens here. Okay. So let's go back. Yep. Now what you can do is you can go ahead, create a new, basically copy paste that project into a new file and listen using the same client. Look at the library syntax. Listen from the same basically MQTT broker and maybe blink an LED every time you get a message. Right? It's not that difficult. You just need to listen, and I'm sure you'll figure it out. If you can't, you all can always message me on Discord tomorrow, and we can during Chrome Dino session before or after for a bit. I think it's only my session in the afternoon tomorrow. Let's quickly check. So I think it's only my session tomorrow, so we can just before or after sit down and break it down. Awesome. All right. So here's the start drop. Whoever and how many of y'all, of course, we'll do a lucky draw if multiple of y'all do it. I want at least, I'm expecting at least 5 to 6 of y'all to actually complete this. And Shamali, you can just make something from your IoT kit that you have. Make the entire thing, send a message of the MQTT Hive MQ thing that you've received, and make a LED blink by listening to the MQTT server. All right, go to the MQTT library, figure out how to do that, and I'm sure you will. And if you all can't, I'll show it to you tomorrow. And only after I'm sure I've showed it to you will we do the swag drop. Okay. So during the Chrome Dino session, maybe I'll start it 15 minutes earlier, and we can quickly go over it, how to do it, and you all can do it. And then whoever posts then or today also, we'll consider them for swag drop. All right. Oh yeah, you can. You totally can. Once you're connected to the virtual Wi-Fi, you can basically use any server, any HTTP request also. Because right now you're basically doing that. So MQTT, that request is actually an HTTP request to some extent. So blink an LED when you get a message from MQTT. Make sense? Or maybe run a motor, whatever. Basically, once you need to create another device and get a message from MQTT. Okay? I know you all can do it. All right, folks. I am gonna close the session a little earlier than usual today because of course I'm not at home and the Wi-Fi is not great, and my camera's obviously been dancing around. But yeah, I will see you tomorrow for Chrome Dino. If you all have questions or anything like that, I'll either start it a tad bit early or we'll stick around for a bit. I'm still not sure if there are any other sessions tomorrow or not. Let me quickly check. Mm, mm, mm. Yep, there is no session after mine tomorrow, so we'll just do it after the session. Cool. Awesome. Well, thank you so much for joining in and sticking around. I know the last part of IoT gets a little confusing and a little daunting to some extent, but y'all are amazing for sticking around and trying. And I will see you tomorrow for a mini event. We'll just have fun tomorrow. No technical talk until after the Chrome Dino. So I'm not at home today. I'm taking this from a WeWork. Thank you, Gaming Sir. Bye, Kunal. Well, have fun at school, Shamari. Even if you can't do the task today, I'll show you how to do it tomorrow, so don't worry about it. All right, folks, I'm going to close the stream now. I had so much fun. I hope you all did too. And I'll see you tomorrow.